In this video, I'm going to look at changing the subject of a formula by looking at two examples, starting with the formula for a simple pendulum and changing the subject from T to L. The reason for starting with this example is because of a video I was involved in producing a number of years ago. It featured some students tackling the same problem. First of all, the students divided through by 2π, which is what I would do. However, one of the students didn't understand what was going on. Why did they divide through by π? Why not move the g first of all? Do we work from left to right? The other students knew what to do, but couldn't clearly explain why. So in this video, we will look at this problem slightly differently and hopefully explain the why. But before we do that, I'm going to finish off the problem that's been started, so that I can refer to this later, since what I'm covering in this video kind of deconstructs, or shall we say digs deeper into this approach, and will hopefully provide some clarity for those of you who are struggling in this area of mathematics. So we've divided through by 2π first of all. The next thing we're going to do is square both sides. So this gives us t over 2π all squared, which is equal to L over g. And then finally we multiply through by g. So we end up with g multiplied by t over 2π all squared. And that is equal to L. And there's our answer. I'm going to refer to this approach as the traditional method. Now, a formula is an algebraic relationship between two or more variables. When we change the subject of the formula, we need to maintain that algebraic relationship. And this process of changing the subject of a formula is often referred to as the transposition of formula. But you probably knew that. Now, what you've probably noticed about a formula is that it is essentially an equation. It's a special kind of equation, as the relationship between the variables link to a particular phenomena, in this case a simple pendulum. Now remember, an equation is where two expressions are equal. I covered this in another video. So essentially, on the left hand side of the formula is an expression which is the term t, and on the right hand side is the expression 2π multiplied by the square root of L over g. And in many cases when you see a formula, you will probably have one variable on one side of the equal sign and a combination of terms, variables and coefficients on the other. Now in this example, it's the right hand side where the L is, the thing that's going to be the subject of the formula. And I'm going to start by putting a circle around the L. We now need to work out the order in getting the 2, the π and the g from the right hand side of the equation over to the left hand side. To help us in understanding the order in which to do this, I'm going to start by building from scratch the expression on the right hand side of the formula, starting with L, the variable that is eventually going to be the subject of the formula. Starting with L. The first thing I'm going to do is divide through by g. So we end up with L over g. The next thing we're going to do is find the square root of L over g. I'll write it like this. So we now have the square root of L over g. Next, I'm going to multiply by π. So we have π multiplied by the square root of L over g. And finally, we're going to multiply by 2. So that's 2π multiplied by the square root of L over g. And there's how we've built up the expression on the right hand side of the formula, starting with L. Now I could have multiplied by 2π in one go and got rid of one of the steps, but let's keep it like it is. So there is our expression on the right hand side of the formula. I'm now going to use this information to make L the subject. To make L the subject, I have to get everything else over to the left-hand side. And as I move the 2, the pi and the g over to the left-hand side, I'm going to be building up an expression on the left-hand side of the equal sign, starting with the term that's already there, t. Now when we are transposing, that is moving a term, variable or coefficient from one side of an equation to the other, we do the exact opposite. So an addition becomes a subtraction, a multiplication becomes a division, and so on. So when we are moving everything over from the right-hand side to the left-hand side to leave L on its own, we are going to do the exact opposite to how we initially built up the expression on the right-hand side. So we are going to do the exact opposite to what we have here. I'll show you what I mean. We begin with the letter t, the term that is already on the left-hand side. Working in the opposite direction to how we built up the expression 2 pi multiplied by the square root of L over g, we start here with the multiplying by 2. To get this 2 over to the other side, we do the opposite of multiplying, which is dividing by 2. So we end up with t divided by 2. The next stage is to deal with multiplying by pi. The opposite of multiplying is dividing by pi. So we now have t over 2 pi. Now, as I mentioned earlier, we could have done the 2 and the pi together. That is, multiply by 2 pi on the right-hand side. And so the opposite is therefore divide by 2 pi. I'm going to stop there. Notice what we have built here is the same as what we have here in our traditional approach. The next stage is to deal with the square root. Well, the opposite of finding the square root is to square. So this gives us t over 2 pi all squared. Again, look at the working out in the traditional approach. And finally, we have divided by g. And the opposite of dividing by g is multiplying by g. So we end up with the expression g multiplied by t over 2 pi all squared. And there's our formula for a simple pendulum where L is the subject. So look at how we've built up the expression on the left-hand side and how it correlates to the working here in our traditional method. We began by building up the expression on the right-hand side of the formula where L is. And in order to get everything over from the right-hand side to the left-hand side to make L the subject, we worked in the opposite direction to how we built up the expression on the right-hand side. It's important to emphasize that how we made L the subject of the formula has nothing to do with working from left to right. That's just a coincidence. So when changing the subject of a formula, you need to be comfortable with building up expressions from terms, variables, and coefficients. Let's use this same approach with one more example. The square root of h squared add 4r squared is equal to L. Make h the subject. Notice this time that our subject, which is going to be h, is on the left-hand side of the equation. This doesn't change anything as to how we approach making h the subject. I'll begin by putting a circle around the variable h. So I now need to work out the order in which I get everything over from the left-hand side of the formula to the right-hand side of the formula in order to get h on its own. As with the previous example, we'll begin by building up the expression on the left-hand side of the equal sign, starting with h, the variable that is going to be the subject of the formula. The first thing we're going to do is square the h, so that we have h squared. Next, we are going to add 4r squared. So we have h squared add 4r squared. And finally, we are going to find the square root of h squared add 4r squared. And so we end up with the square root of h squared add 4r squared. So that's our left-hand side of the formula. We now need to make h the subject of the formula. So we are going to build up an expression on the right-hand side of the formula, starting with L, and we're going to do the exact opposite to what we did here when building up the expression on the left-hand side of the formula. The first thing we are going to do is the opposite of finding the square root, which is to square both sides. So we end up with L squared. Next, we're going to do the opposite of add 4r squared, which is subtract 4r squared. So we now have L squared subtract 4r squared. And finally, we do the opposite of squaring, which is finding the square root of both sides. So we end up with the square root of L squared subtract 4r squared. And there is our formula rewritten with h as the subject. Let's compare this to the traditional approach. So if I was doing this, the first thing I'm going to do is square both sides. So we end up with h squared add 4r squared is equal to L squared. Next, we're going to subtract 4r squared from both sides. So we end up with h squared is equal to L squared subtract 4r squared. And then finally, we find the square root of both sides. So we end up with h is equal to the square root of L squared subtract 4r squared. So look how the traditional method correlates to what we've done here. What I've been showing you is essentially the traditional method. I've just wanted to dig a bit deeper to see how the traditional method works and why it works. So this work is really about understanding how the formula is constructed and knowing how the expressions are built up on the left-hand side and the right-hand side of the formula. Of course, the key to this is plenty of practice. So just to recap what I've been doing in this video. Circle the variable that's going to be the subject of the formula. Then starting with that variable, build up the expression around that variable. And then finally, to get that variable on its own, you're going to build up an expression on the other side of the formula, working in exactly the opposite way to how you built up the original expression. As we can see, what I've done here is not far removed from our traditional method. What I'm showing you is the nuts and bolts of how the traditional method works, and I hope what I've done here helps you in that thinking. But there's a brief look at one approach on how to change the subject of a formula. I'll do some more work on this in another video. But that's it for now, and I hope you found it helpful. Thank you for watching.